Hey guys, what's up? Alright, so first, Christ my God, please forgive me for my sins, and yeah, bless this video, and be with all of your followers, and bring the rest of them to you. And second is, I've got two limits here. They are both from Michael Spivak's calculus book, which I have again and again said is the best calculus book ever written. Right now, we've done limits that are similar to this one at least, and maybe even this one, right? But you know, these are different from any that I've already done, and so, you know, warrant this video. Okay. Let's get on with it, yeah? Okay. Alright, so anytime you see tan x and x and a quotient, you should be thinking of that, you know, very famous limit, which goes like limit as theta goes to 0 of sine theta over theta is equal to 1, right? Alright, now I have proved this limit in 2 different videos, right? So, shut up! Okay, so I have proved this limit in 2 different videos. I'm not saying peace, two different videos. Yeah, okay. And so, you know, check that out, but we're gonna make use of this limit and both this and this. And since Spivak has used Roman numerals to number these, there, okay. This marker is stronger than I'd like. Alright, but I guess it stands out. So on this one, we go, you know, when you're at a dead end in a math problem, it's a good place to be because, well, you do the only thing that you can do. So to start, you know, we can't really do much, so we express tan x as sine x over cosine x, right? And so then this is the same as limits x goes to 0 of, well, key flip change, right? So it's going to be cos x and then times x, right? This is not the argument of cosine. That x I put in parentheses, that x right there, and then otherwise we have over sine x, right? Sine theta over theta. So we kind of have that going right here, but not quite, right? Not an issue. This is a clever rewriting that you should be used to at this point. So what we're going to do is we're going to cleverly rewrite x over sine x, at the same time apply the limit product law. So if we do both, then we go lim is x goes to 0 of cos x, right? Times, and this is the clever rewriting I'm talking about, lim is x goes to 0 of, well, x over sine x is the same as 1 over sine x over x. Clever, huh? Okay. Now, this here is cosine of 0, which is equal to 1. And once again, applying the limit law, we could just concern ourselves with the limit here, and we know that the limit here, right, this here is 1. So we've got 1 over 1 in this part, times 1, and so this whole thing is equal to 1. Yeah? Okay, cool. Now, we know that 1 minus cosine squared is sine squared. So you can already see the writing on the wall, or on the board. Okay. But the only problem is the numerator doesn't say 1 minus cosine squared. Not much of an issue. So we take care of that like this. So we go limits x goes to 0 of -1, right? And then plus cos squared, right? So first, like, you know, have the 1 and the cosine appear where they ought to. But then, you know, it's not a big deal from there. We go, alright, we're going to factor out a -1. So we go, limits x goes to 0 of, factoring out a -1, we go -1 times 1 minus cos squared. X over, of course, the denominator is still x squared. We see. So first, using the limit laws, we can put the constant -1 right all the way in front, right? So we go -1 right here, right? Okay, so it's -1 times blah, blah, blah. And then second, we see that this is sine squared, right? Okay, my hand seems to do better with this marker. So 1 minus cosine squared, as I said, is sine squared, all right? We need the space, that's why I'm having erase and all that good stuff. So we go, all right, this is -1 times lim is x goes to 0. Now we should see where to go. So we're going to go sine x over x, and then times lim is x goes to 0 of sine x over x. So what I've done is I've split sine squared is sine times sine, and x squared is x times x, and at the same time applied the limit product law. And so then this here, by that famous limit, is equal to 1. This here is equal to 1. So what we've got is negative 1 times 1 times 1, which makes negative 1. Yeah? Okay.